Lorenzo Bastonero, and I'm a PhD student at the University of Bremen on the Excellence Chair of my supervisor, Professor Nicola Marzari. And for the AiiDA tutorials of October 2022, I'm going to show you the new capabilities of the upcoming release of the new version 1.0 of AiiDA-Phonopy. So AiiDA-Phonopy and Phonopy allows you to compute phonons in the harmonic approximation, and phonons allows you to access different information such as the structural stability, thermal properties, and so on of your materials. But to evaluate phonons, one needs to compute the second order energy derivatives in respect to atomic displacements. And we have mainly two ways to compute these phonons, either via linear response method or via finite differences. Finite differences exploit the supercells approach and are more general. And Phonopy is a package that allows you to get this supercell and also to do the post-processing part to get the phonon information. So since this method produces many different supercell structures, then it is very useful if this can be automatized and it can be interfaced with workflow managers such as AiiDA. This is the reason why we develop AiiDA-Phonopy to make Phonopy interface with AiiDA. So early versions are thanks to Abel Carreras and Atsushi Togo, and I continued their work. So at the beginning, this is, as you can see, is the workflow that you can find also on the Phonopy webpage. And at the beginning, AiiDA-Phonopy could only interface VASP and Quantum Espresso. And so we understood that in order to make AiiDA-Phonopy interface with any code, we actually needed to subdivide this workflow. And to do so, we actually realized that using data types could actually allow us to do so. And so we introduced two new data types, that is the pre-processed data that simply will generate the supersets with the needed displacements, on top of which one needs to evaluate the forces with any code that one wants to use. And then the Phonopy data, which actually gathers together the pre-processed data with the forces in order to gather all the information together for an easy to use post-processing. Of course, Phonopy and AiiDA-Phonopy don't allow you to actually compute those forces, but you can use any code that you want to. And of course, also another great thing of the new release is that we improved the Phonopy calculation to access all the possible post-processings that Phonopy already allow you to compute. And so I also prepare a practical overview, and also I want to remind you that there is a YouTube video that contains the information for different applications, also the old version of the Phonopy, AiiDA-Phonopy. So here I prepared this little Jupyter notebook to show you the main new capabilities. So as I said, we actually have a pre-processed data that we can import from the data factory. And we can actually import silicon structure from the COD database with this ID. This is also shown in the AiiDA tutorials. And this structure, it actually has 8 atoms. So we can import it quite quickly. And then we can actually now start to build our pre-processed data object. So for do so, we need to specify a supercell matrix. In this case, we define a 2x2x2 supercell matrix. And it is very, very easy, as you can see here, to initialize this object. And then now, from this pre-processed data, we can actually access the supercells with displacement on top of which we want to calculate the forces. So running this cell, as you can see here, we just have one supercell structure because the silicon structure is supersymmetric. And as you can see here, we actually produced a structured data that can be immediately be used in different codes and force calculators that already interface AiiDA. So also to show you that we actually produced a supercell structure, we actually have here 64 atoms, as we would expect. So now we need to run some codes to evaluate the forces on top of this structure. And here I show you 3 lines that you can use also to evaluate these forces using Quantum Espresso. And I won't run this calculation since it would require some minutes. But we can, let's say that we already finished the calculation, and then we actually want to gather together all this information to perform this post-processing part. So we can define the Phonopy data from the pre-processed data that we generated before. And now we just need to set the forces that I already computed before, and now I can just easily load using this method of set forces. And that's it. We can now easily do a post-processing calculation using the improved Phonopy calculation calcjob. As usual in AiiDA, we just use the calculation factory and we get the builder. And as you can see here, also now the interface of this new calcjob is very user-friendly because the only parameters that you need to provide are the Phonopy data, of course, which contains all the information you want for the phonons, and the parameters is actually the parameters that are needed to that you want to post-process. So in this case, we are just requiring a band calculation in an automatic mode, and of course, we also want to specify a code. And then we submit the calculation to the daemon, and as you can see here, if we type Verdi process list, we actually see that the Phonopy calculation is running and it has been submitted. And hopefully now this post-processing part is very fast, and as you can see it's finished, and we also can check that it's finished okay, and we can access now the outputs. So in this case we have the output parameters that contain different informations. For example, the Phonopy version that we used, that is the 2.14.0, which is not the latest, but it's quite recent as well. And also we have other different information regarding symmetries and units. Also, since we computed the phonon band structure, we can actually access the phonon bands and show it using matplotlib. And as you can see here, we have a nice silicon band structure computed very easily using supercell approach and Phonopy. So with this, I want to conclude just with some future perspectives. AiiDA-Phonopy is going to be, with the new version, is going to be released very soon. And also future projects that are going to automatize the AiiDA-Phonopy workflow are AiiDA Vibroscopy, which is built on top of Quantum Espresso and AiiDA Quantum Espresso, and also AiiDA Common Workflows that allows you to compute forces using more than 10 different quantum engines. And then we are also going to implement an automatic workflow for phonons in this package. And other future perspectives are also the extension of the calcjobs to the quasi-harmonic approximation and the implementation of AiiDA-Phonopy for the line width of the phonons. And with this, I also would like to suggest you to follow the AiiDA-Phonopy GitHub page to stay up to date. And with this, I thank you all for your attention.